Alright, we only have two more lessons to go in this chapter. This lesson is more segments inside of a circle, so they're special segments. We'll be looking at more secants today. Okay, so when two chords intersect inside of a circle, each chord is divided into two segments called chord segments. In this figure here, chord AC is divided into segments AB and BC, and the same is likewise for chord ED is divided into segments EB and then BD. So there's a theorem that states that if two chords intersect inside of a circle, then the products of the lengths of the chord segments are equal. So basically AB times BC is equal to DB times BE. Okay, this is going to help you find missing measures within a circle, this theorem here. So all you're doing is taking the product of each chord segment and setting them equal to each other. Okay, so on part A, it says to find x. So based on that theorem we just discussed, I know that since AB is 5 and BC is 12, I know if I do 5 times 12, I can set that equal to x times 10. Okay, so I know that AB times BC is going to be equal to EB times BD. So like I just said, 5 times 12 is equal to x times 10, and I just use algebra to solve for x. Okay, so 60 is equal to 10x, so x is equal to 6. Alright, and that's the answer. I want you to pause the video now and try to do part B on your own. Again, you're just going to use algebra, so if you're multiplying two binomials, you will have to FOIL them out. Alright, let's check and see how you did. So again, these are two chords that intersect inside of the circle, so I know that PK times KM is going to equal to JK times KL, and I can find the value of x. Alright, so JK times KL is going to be kx plus 10 times x equals x plus 1 times x plus 8. Okay, so here all you have to do is distribute x to every one side of the parentheses, and then you're going to have to FOIL this guy out on the right side of the equation. When you distribute x, you get x squared plus 10x, and then that is equal to x squared plus 9x plus 8 when you FOIL the two binomials. To simplify, you bring the x squareds on the same side of the equation. They cancel each other out, so then you're left with 10x equals 9x plus 8. And then when you solve for bring 9x onto this side of the equation, you get x is equal to 8, and that's the answer. Alright? So it's pretty easy formula, right? When they intersect on the side of the circle, the two chord segments, if you find their products, they should be equal to each other. Alright, so let's apply this to a little science. So the true shape of a rainbow is a complete circle. However, we see only the arc of the circle that appears above Earth's horizon. What is the radius of the circle containing the arc of the rainbow shown? Okay, so what is the radius of the circle containing the arc of the rainbow shown? So remember, this rainbow is going to make a complete circle, and all that is showing is just this little bitty top portion of the entire circle. Okay, so let's draw the picture to make it look like an actual circle. Okay, so if we were to draw this as a circle, the only portion of the rainbow that is showing is the arc ADC. Okay, so if you were to draw it as a circle, this is what you end up getting. Alright, so if I'm asking you what the radius of the circle, since DE is a diameter, if I find the diameter, I can just find the diameter and divide it by 2. Okay, so all that I'm given now is I have AB and BC and then 0.7 here. So if I find out what BE is, I can find out what the entire length of the diameter is. Okay, so using the theorem that I just worked, so I'm going to pause your video here and try to work this problem on your own and see if you get the correct answer. Okay, hopefully you've obtained the right answer. Let's check and see. Okay, so we know that AB times BC is going to equal to DB times BE, which is 2.5 times 2.5 is equals 0.7 times our missing segment length. Okay, and so when you work that out, you end up getting that BE is equal to 8.9. But the problem said, what is the radius of the circle containing the arc of the rainbow? So since I know that BE is 8.9, oh, sorry guys. Since I know that BE is 8.9, I now know that DE is equal to DB plus BE, which is 0.7 times 0.8 plus 0.89, which is 9.6. Well, 9.6 is the diameter, right? So what is my radius? It's going to be that divided by 2. Make sense? So 9.6 divided by 2 is going to be equal to 4.8. And that's my answer. Okay. Pretty cool. Okay, so here's another theorem. A secant segment is a segment of a secant line that has actually one endpoint on the circle, and the figure in this figure here, AC, AC, AB, AE, and AD are all secant segments. A secant segment that lies on the exterior of the circle is called an external secant segment. If in this figure, AB, so AB and AD are external secant segments because they're on the outside of the circle, on the external part of the circle. So we have a theorem that states that if two secants intersect in the exterior of a circle, then the product of the measures of one secant segment and its external secant segment is equal to the product of the measures of the other secant and its external secant segment. Whew! Okay, so look at this figure here, okay? It's easier to just look at it and understand. So what this theorem states is that if I take this entire secant segment AC and multiply it times its external measure, so AC times the external part AB, that is going to be equal to AE times its external measure AD. Okay, so you're taking the entire segment, multiplying it by the external part of the segment, and then the same thing here, the entire segment multiplied by the external part. Okay, so this is going to be able to help us find measures outside of our circle as well. Okay, and remember, this is only for secants that intersect outside of the circle. So using this problem here, I want you to find the value of x. Okay, pause the video and try to do this on your own for a second. All right, based on that theorem, I know that I can multiply JG times JH and set that equal to JL times JK. Okay, so JG, we don't know the entire length, but I do know that it's x plus 8, and I know JH is 8. And I know JL is going to be 10 plus 6, and then JK is just 6. So working this out with algebra, I end up getting that x is equal to 4. And you're done. Okay, so a similar equation can be used when a secant and a tangent intersect outside of a circle. So remember, a secant line intersects inside a circle. Tangent lines only touch the circle. So this theorem here only works for the ones that intersect inside of a circle. But this one here is for if we have a secant and a tangent. Okay, so in this case, the tangent segment, or the segment of tangent with one endpoint on the circle, is both the exterior and the entire segment, because remember, a tangent line does not go inside of the circle. So here's the theorem. If a tangent and a secant intersect in the exterior of a circle, then the square of the measure of the tangent is equal to the product of the measures of the secant and its external secant segment. So basically all you do is you square the tangent segment. So here, JK, you square that. That's going to be equal to JL times the entire segment JM. All right, very similar to the theorem we just discussed. This part right here it's the external measure times the entire secant, but you're going to set that equal to the tangent squared. All right, so using that theorem, here we have PQ as a tangent on the circle, and I want you to find x and round to the nearest tenth. Okay, pause your video and try to do this on your own and come back and we'll check your answer. All right, let's go there and see what you got. So we know that PQ is a tangent line, so what I can do is I can set 8 squared equal to x times x plus 7. Okay, that 8 squared equals x times x plus 7. Now I just use algebra to solve for x. So I have 64 equals x squared plus 7x after I distribute my x to every one inside of the parentheses. Okay, so now remember, guys, whenever you have a quadratic equation, you have to set it equal to 0 before you can solve, and then try to factor it. If it's unfactorable, we have to use the quadratic formula. And I'm not sure if Ms. Lytle sang this to you guys last year, but if not, remember it's x equals negative b plus or minus square root of b squared minus 4ac all over 2a. All right? So remember, A is 1, B is 7, and C is negative 64. So when you plug this into the quadratic equation, this is what you end up obtaining for the values of x. Okay? So x can either be 5.2 or negative 12.2. We know that a measure cannot be negative, so get my pen here, so we know that our answer is going to be equal to 5.2. Okay. All right, when I return to class on Thursday, we will do lesson 9.8. In the meantime, I want you to work on your homework in class together. You can work with a partner if you want to, but finish your homework for lesson 9.7 so that way when I come back to class on Thursday, we can go over questions and hopefully begin this lesson.